Hi, hello one. My name is Nayanathikarnalaki and my metric number is F1023 and my group mate name is Somasundresan Alakimaniyam and metric number is F1003 and another group name is Manesha Alaki Siva, it's F1004. And today I would like to talk about Lab 2, the DC converter Halfwave rectifier. For the introduction, a half-wave rectifier converts AC to DC by allowing only one half of the input waveform to pass through via a diode. This results in a pulsating DC output suitable for low power applications like battery chargers, where simplicity outweighs efficiency concerns. And for the experiment outcomes, for the first is assemble schematic diagram of half-wave rectifier using Tinkercad, and for the second is run simulation and observe the waveform using two oscilloscope, and for the third is compare experiment waveform with theoretical waveform. For the objective, first is learn to build a half-wave rectifier circuit using Tinkercad tools and virtual components, and for the second is run simulation to observe voltage waveform across the load resistor and compare result with theoretical expectations, and for the third is experiment with circuit variations and troubleshoot common issues to gain insight into circuit behavior. And the equipment we are using for this lab is first is diode, and second is breadboard, and third is inductor 50 mAh, and fourth is resistor 180 ohms, and five is oscilloscope 1 ms, and last is function generator frequency 200 Hz. And for the theory it's very simple, that a rectifier is an electrical device that converts alternating current AC, which periodically reverse direction to the direct current DC, which follows in one only direction. And this proceed to the procedures. For the procedures, first we want to do that search Tinkercad website, the www.tinkercad.com, and click join now. And for the second is click circuits and create the new circuit. And for the third is select place components and the draw route using schematic below and the start simulation as shown in the slide. And as for the result, show the experiment waveform from the oscilloscope and prove the result with theoretical waveform. For the A is output voltage V out. Here is the diagram of the circuit and the theoretical waveform. And for the B, output current I out. Here is the schematic diagram of the Tinkercad and the theoretical waveform. And for the C is resistor voltage VR. Here is the circuit diagram for the Tinkercad and the theoretical waveform of the resistor voltage. And for the D, inductor voltage, here is the Tinkercad circuit voltage, the Tinkercad schematic diagram, and then the waveform of the inductor voltage. And for the discussion that we can conclude from the result is the half-wave rectifier is a basic DC converter that transforms AC alternative current into direct current by DC by allowing only half of the input waveform to pass through via a diode. Although simple and cost effective, it is less efficient than full wave rectifiers. Commonly used in low power applications like battery chargers, its limitation in efficiency and output quality prompt consideration of alternative method of higher performance applications. And for the conclusion that we can conclude is, in summary, the half-wave rectifier efficiently converts alternative current to direct current, that DC, by allowing only 1.5 by the input waveform to pass through. While cost-effective and commonly used in low-power devices like battery chargers, its efficiency is lower compared to the full-wave rectifiers. This simplicity comes to the threat of prompting exploration of alternative methods for application requiring higher performance. And that's only, madam. Thank you for me.